Okay, it's time. Can you hear me?
Yes, yes.
Okay. Hello, everyone. I'm the station chair and of the first station, and I'm Yuting Qin from Shanghai Jiao Tong University. And this station, we will have 3 presenters about software design and development. And the first presenter, Chen Yang, since he's in a trip, and I have to play the video and just enjoy. Okay.
Hello, everyone. My name is Yang Chen.
Wait.
From National University of Defense Technology. Now I would like to show you my work in empirical study of multi-distancing patterning in open source software development. My presentation has 3 parts: background, research background, research method, and research result. First, research background. In GitHub, the world's largest open source community and issue mechanism has been set up for technical discussions in all bugs in the development process. For developers to put forward problems and solve problems together, generally speaking, it is similar to technical discussion posts for projects. The issues mechanism plays a very good role in promoting the efficient development of the project. We found a very interesting phenomena in the process of researching the issue. That is, in the same period, the same developer and the discussions in multiple issue posts the meaning of our multi-topic, so that they would contribute to the resolution of multiple issues. As shown in that figure, a developer named Fortune discussed issues numbered 32941 on May 21st. That discussed semantic diagram format discussing between 2 or more different issues. Developer X promotes the resolution of issues through discussion on different timelines in the same time period. First, after our previous course grinned, we found that there were positive and negative aspects in less multi-discussing. As should know positive aspects by paying attention to various issues. Developers can maximize their working potential and make more contributions at the same time. There is also negative aspect. That is, if a developer pays too much attention to multiple issues, the attention of developer will be greatly dispersed, which may have a negative effect on the solution of a single issue. Second, in addition, and no relevant research was carried out at the issue level. In view of above research background, we put forward 3 questions here. First, whether multi-discussion will have impact on the overall issue resolution of the project, whether it will promote the issue resolution of the project more quickly or delay the resolution of the overall issues of the project, or it will have no obvious effect on the resolution of the issues of the project, and the correlation is relatively weak. This is the first issue we are concerned about. The second is that multi-discussion has the same impact on the solution of a single issue or have no previous influence on the solution of a single issue, the correlation is weak. The final question is, what experience or expectations do developers have in the multi-discussing? Less information can help us to understand the connotation and the development key to multi-discussion from a human perspective. After talking about research problems, we will focus on the research methods we use, which mainly include the data sets we used and the concepts we've defined. We screened 624 GitHub projects from GitTorrent, all of which had more than 3,000 issues. It should be emphasized that the issue we refer to here is ordinary.
Hello. Can you hear me? Hi, Lin, can you hear me?
Yes, yes, I'm
Yeah,
connecting.
so the video is dropped.
Yeah, I think it's problem of the Providence network from contact now.
Oh, okay. So maybe can you take over the set chair for the next speaker? So maybe
Sure.
we can play the first audio later, right?
Yeah. So okay, in this case, how about the next process?
Yeah, next author is I think it's a 3D, right? 3D, I hear.
Yeah, will you please share your slide?
Yeah, I'll give you the you can share now. Yeah, 3D.
Yeah, 3D. Please share your slides. Okay.
Hello, can you hear me?
Yes, because of the network error. Now let's switch to the next author, who is from Xi'an University, and he was given a talk on in paper study of architecture changes in code commits. Let's enjoy.
Yeah, I will present our work in a video and answer the question next.
Okay, please. Actually, I think the voice is too small for your talk. Can you adjust the volume?
Okay.
Maybe you have the micro so that you can put your micro close to your speaker.
Okay. Can anybody hear clearly?
We can hear clearly for your voice, but not your not your video.
Okay. Okay, can the voice louder enough?
I think you can click when you share the video. So there is a checkbox you can click so to share the audio. You can you can try to share again. Yeah, this is not clear, right?
Not clearly?
Yeah.
Okay, I will stop the sharing and sharing again.
Hi, so I gave you a WeChat messages. Maybe you can try with the settings on your Zoom.
Okay, I will. Good morning, everyone. Can you hear clearly?
Yeah. Now it's okay.
Okay, I will play the video. Okay. My name is Di Cui, a PhD student from Xi'an Jiaotong University in China. Today, I will present our work. The title is An Empirical Study of Architecture Changes in Code Commits. My presentation has 5 main parts, including introduction, methodology, evaluation, threat to validates, and conclusion. As we all know, almost every software evolves to meet the increasing requirement of users. The software evolution process including requirement evolution, environment evolution, source code evolution, and so on. The code change dominates the activities in software evolution through software systems life cycle. In most cases, source code changes are committed for adding new features, fixing bugs, refactoring, and so on. However, analyzing and understanding source code changes is not easy. We use the top 50 start Apache open source projects as an example. These figures present the distribution of the statistics of commit per day and the length of code per commit for these 50 projects. We observed that these projects evolve with a fast speed, almost 4.6 commit for a day, and also with a large amount, at least 200 modified length of code for a commit. Thus, a natural question arises that do developers really understand what they changed? For example, a Windows kernel developer once complained that he only left a few weeks, and when he came back, he fell behind almost 60,000 commits. The two features of code commits, fast delivery and large amount, finally result in the architecture decay, which is a known phenomenon of critical maintenance issues. Related work also pointed out that most of developers are not aware of the architecture impact of their changes, thus causing the architecture decay. Peter Brook only once said, "You cannot manage what you don't measure." So in this paper, for commit, we proposed an automated architecture change detection tool and conduct an empirical study of architecture changes in code commits. So let's talk about the methodology of our detection tool. Before introducing the methodology, we first illustrate some preliminaries. For a code commit, we model it as a tuple with hash ID and a set of modified files, file set. For a change unit, it represents modifications on source code. Each change unit have six parts, including the position, change the position, file, operation, the type of the change unit, the begin len, the end len, and the name of the change unit. The operation can be further have three types, including insert, delete, and update. As for a change relation, which is actually a relation between two change units, including three types, including contain, diffuse, and replace. The combination of the change unit and the change relation finally constructs a change graph. So, based on these preliminaries, we design our architecture change detection tool with two steps. We first construct change graph from the commit. In this step, we use gum tree to parse changes into ASTs and use Spoon to obtain change units and change relation as the change graph. Next, we mine architecture changes. We use DSM to analyze the change graph for detecting architecture change in code commits. We use a running example to illustrate the process of our detection tool. For the code change in schema.java in commit F4, B, 2, 1, F5, we first pass them and these changes into a change units. Then we detect the change relation between these change units and construct the change graph and further obtain the change DSM. We search the whole change DSM to detect the relation marked in red as the architecture changes, and thus this commit F4B 21 F5 can be regarded as an architecture commit. We evaluate 4 research questions to advance our understanding of architecture changes. The first question is that how often do developers introduce architecture change commits? The second question is that what are common and risky intents under which developers introduce architecture changes? The third question is that are modified numbers of length of code in code commits critical indicators of architecture changes? The fourth question is that are involved a number of source of files in code commits critical indicators of architecture changes? We collect the data and evaluate in 16 study subjects involving 368,847 commits. For each project, we collect code commits using glog comment, and we also obtain architecture change commits using git to check out in the involved files, and further employ our detection tool to further detect the architecture change commits. For the first questions, we count the statistics of the architecture change commits and observed that almost 53.4% of commits introduce architecture changes, and on average, developer contribute 5.6 commits for a day and 3.3 commits to introduce the architecture changes. For the second research question, we trace each commit into the report in Jira, including 6 types of reports, which have bug, improvement, new feature, tasks, test, and other. When analyzing this data, we observed that bug fixing is the most common intent when introducing architecture changes for having the largest number. Implementing and improving features have the highest probabilities to introduce the architecture changes. For the third questions, we evaluate its correlation using Kinder matrix and observed that the modified length of code doesn't have a strongly positive correlation with the architecture changes. It cannot be regarded as a feature or indicators for architecture change commit. For the first questions, we evaluated like RQ3. We observed that the modified number of sales files doesn't have a strongly positive correlation with architecture changes either. It can also not be regarded as a feature or indicators for architecture change commit. We finally evaluated the accuracy of our detection tool manually. We sampled 200 positive samples and 200 negative samples and evaluated them with students manually. We found that our detection tool has a relative high accuracy. The precision is high at 71%. The recall rates can be 79%. The F1 measure can achieve 75%. So, after analyzing the results of RQ1, 2, 3, and 4, the implementation of our study is that for developers, it's imperative to monitor the architecture changes and report them in time. For the research community, 2 natural questions rest to be solved. The first one is, when should we evaluate the effect of continuously architecture changes? The second one is, are existing architecture change impact measures ready to be used from the effectiveness and the efficiency to elevate the burden of the developers? So let's talk about the limitation of our study. The limitation of our study includes 4 parts. The first one is the definition of the architecture change used in our paper. Actually, the definition of the architecture change is uncertain, and we select the easiest understood one. In our future work, we plan to evaluate other definitions. Second, our study suffers from the linking problem. When we answering the AQ2, we link commits into JR reports. The linking efficiency can achieve almost 70%, but actually this is not enough. In our future work, the linking algorithm can further be improved. The third question is that our results limited in 16 Apache open source projects. In our future work, exploring more subjects in other communities and also in some closed projects is deserved. The last one is that our study may be influenced by the quality of the collected data. It's really a long-lived, and also should be our future work to maintain it, to always maintain the data. So, in summary, we proposed an automated architecture change detection tool. And based on this designed detection tool, we further conduct a large-scale study on 368,847 commits of 16 Apache open source projects. Our study advanced the understanding about architecture changes and provide practical implications for software developers, and also shed light on potential research directions on architecture maintenance. This is our presentation. Thank you. Do you have any questions?
It seems we have a little out of time budget, and we may have one quick question. And any question? And we just have one question. Okay, how can this work be applied to? Let me check. Okay, how can this works findings be applied to the real projects, or what insight it brings to real software development? And this question.
Can you hear clearly? And the work in this work, the extent of our work about architecture changes in code commits can actually apply to the fix of bugs or some of even vulnerabilities. Actually, in our recent work, we found that the architecture change actually is a solution. Is also a common solution to fix bugs, and which can further help us to predict something wrong, a bad fix, and even help us to generate automatically generate the bug fix. Okay.
So if we anyone still have any questions, and we may send an email to the authors, and so let's thank the speaker again. Okay. Then we will move to the next talk. The next talk is come from Nanjing University. The presenter is Wei Yuyang. And hi, Wei Yuyang, are you there?
Yes, I'm here. Can everybody hear me?
Yeah, sure.
Okay, I will share my screen. Oh, I have. Oh, okay. Now I can share my screen. Okay. Can you see the PPT of my presentation?
Sure.
Okay, I will start my presentation. Hello everyone, I'm Wei Yuang from Nanjing University, and today I'm going to present our study of decomposing monolithic applications into microservices through a feature table approach. The outline of this presentation is as follows. First, I want to introduce the background and related work of our approach. To understand what is microservice, we should first know what is monolith. A monolithic application puts all its functionality into a single process, while a microservice architecture puts each element of functionality into a separate service. This is the most fundamental difference between them. Monolithic architecture was widely used in the past, but as the applications grew in size, the disadvantages of monoliths will be exposed. Here are the two main problems. The first one is about bug fixing, and the second one is about startup time. To solve these problems, microservice architecture was proposed. It was first described in detail by Lewis and Fowler. Two important parts of the definition are marked right here. The first one is running in its own process, and the second one is communicating with lightweight mechanisms. Nowadays, microservice has become a trend. In comparison, microservice had the following advantages. First, they fostered independent deployability. What's more, they can be developed by different technology stacks. Netflix, Amazon, and eBay all have migrated their applications from monolithic architecture to microservice architecture. They are the widely used microservice frameworks and communication mechanisms. Spring Cloud and Dubo are both based on Java. Namico is based on Python. Nonetheless, microservice architecture is not a panacea, and it also brings many issues to be addressed. There are two ways to develop microservice applications as is presented here. We focus on decomposition, and one issue is how to decompose monolithic applications into microservices. There are some related works on how to decompose monolithic applications. This survey introduces 10 different approaches by this search method. We can see some keywords here. Here we introduce 3 related works. The first one is based on data flow, the second one is based on graph partitioning, and the third one is based on API analysis. Based on the classification method mentioned in the survey, they are tagged with these labels. These labels show how these approaches work and where they can be applied. Workload data-aided approaches means this approach decomposes monoliths by measuring the application's operational data on module or function level. Metadata-aided approach means this approach uses abstract input data like architectural description in form of UML diagrams, use cases to decompose monoliths. None of these applications can generate runnable results. In comparison, our approach is based on the features of functions. It's a workload data-aided approach and can be used in monolith migrations. Our approach can generate a runnable result. Next, I will introduce our approach. There is no recognized good decomposition approach currently. Thus, we proposed a feature table approach to decomposing monolithic applications into microservices. This is the workflow of our approach. Our approach relies on the source code of monolithic applications. The output is microservices based on Spring Cloud. There are many 3 steps in our approach. The first step is to apply the decomposition rules. Decomposition rules are based on artificial decomposition currently. With decomposition rules, monolithic applications are decomposed into these three different parts. They are functional modules which reflect the correlation between functions, and functions which represent the business capabilities of applications, and entities which carry the data of functions. This picture shows the results obtained by decomposition rules. In the second step, we use the self-designed feature table analysis tool to analyze the functional modules and functions obtained in the first step. In this step, we can get the microservice candidates. This is an example of feature table. We can see that there are functional modules, functions, correlation weight, and features. The whole feature table is too large to present here, so we just present part of the table. Before introducing feature table analysis tool, I should introduce the feature cards we designed first. Feature cards are used by us to define the features that are related to microservice and the correlation weight between them. Feature cards contain these elements. They are feature name, description of the feature, the category of the feature, and the correlation of the feature with microservices. Currently, there are 12 different feature cards. Here, we present 2 of them, backend related and data storage. Backend related is a precondition. In our microservice applications database, there are 65 functions that have the feature data storage. In these 65 functions, there are 53 functions that are considered suitable for microservice. So the weight of data storage is 53 divided by 65. So we keep one decimal place as a percentage. That's the way we define the correlation weight of each feature. These are all the 12 features, and there are 6 categories. We collected a microservice applications database as a benchmark, and it contains 14 applications, and there are 230 business functions. We defined the evaluation algorithm of feature table. The feature backend related is a precondition. If it's satisfied, we should compute the summation of group average weights. I will explain group average weight later. Next, I will introduce the last step of the workflow, which is mapping rules. With mapping rules, we can map the microservice candidates to microservices based on Spring Cloud. This is a schematic diagram of Spring Cloud architecture. We focus on the Spring Boot applications. We define the general microservice module based on Spring Cloud, and this module contains these elements. They are the main class, a controller which provides the URLs of services, service, DAO, entities which are obtained by decomposition rules. For the second step, we designed the analysis tool. It's also based on Spring Cloud. There are 2 services managed by Eureka. The next part is case study. We choose cargo tracking system as a case. It's a monolithic application based on Java and was used by related studies to evaluate their decomposition approaches. So we chose it as a case to compare with the related studies. These are the main functions of cargo tracking system. We can see track cargo by tracking ID, list all cargoes, book new cargo, book successfully, and change destination. The first step is to analyze the functional modules and the functions of cargo tracking system. Here we present the 6 functional modules and 10 functions of this application. Then we need to analyze the entities of this system. Here we present 5 entities related to main functions. The second step is to analyze the functions with feature table. The feature table is too large to present here, so I use the function cargo list of cargos as an example to illustrate how it works. This function has a feature backend related, so we continue to compute because the precondition is satisfied. It also has the features information transmission, search, and timeliness. We should notice that search and timeliness are related to the same category, hybrid time related. So the calculation formula is this. The weights of search and timeliness is divided by 2 to get the average weight of their category. According to the analysis results, we can get microservice candidates shown in this picture. The right picture is a result of reconstruction. It has been open sourced on GitHub. The next part is evaluation. We choose metrics to measuring the cohesion and the coupling of microservices, and we didn't find better metrics to evaluate the decomposition result at that time. The design ideas of evaluation is high cohesion within a microservice and loose coupling between different microservices. We use these metrics to evaluate our decomposition results. Afferent coupling, instability, and relational cohesion. Afferent coupling means the number of classes in other packages or services that depend upon classes within the package or services itself. Afferent coupling means the number of classes in other packages or services that the classes in a package or service depend upon. Instability is the ratio between CE and the summation of CE and CA. 0 means the service is completely stable, while 1 means it's completely unstable. Relational cohesion means the ratio between the number of internal relations and the number of types in a package or service. The first table is evaluation of our approach, and the other tables are the evaluations of related work we mentioned above. We can see that compared with the other approaches, our approach generates a completely stable result. The instability of our approach is 0. As for relational cohesion, our approach didn't generate a better result. The reason is that the specified internal hierarchy of microservice module reduces the interdependence between internal classes and leads to loose coupling. However, we think this hierarchical structure is favorable from the perspective of software development and refactoring. We also proposed some optimization of our approach. The first optimization is the improvement of microservice applications database. We need to add more data and or build a domain-related data sets. In addition, feature cards are a little rough currently. We want to refine the definition of features and define features hierarchically like this picture. We also want to improve automation through node clustering. Hierarchical clustering algorithms can help us determine the appropriate granularity of microservices. What's more, better evaluation metrics are also important. That's all, thanks. If anyone has a problem, please propose the problem.
Yeah, just one quick question, and anyone, you may ask one quick question there. Okay, if no one raises questions, and we may let's thank our speaker again, and we will move to the next talk. Okay.
Okay.
Thank you, and we will still move to the next talk. That is the first talk in our session. The presenter is from National University of Defense Technology, and the talk is about an empirical study of multi-discussing pattern in open source software development. Hi, Yun, and can you play the video again?
Oh, sure. Let me reopen it. No. Can you see my screen? So it's it's easier. Sure. 好，消费there. So the settings does not.
Yeah.
I think your Zoom meeting cannot allow me to share video.
Oh, yeah.
So can you give me some higher priority?
Okay. You can share, right?
I can share, but without my. So make sure. I can only share my single window.
Come from the National University of Defense.
So I cannot share my whole screen. Let me try it again. But I cannot see my screen. I see a video there, but maybe I can only see it. Let me have a try another way.
Yeah, if you cannot, maybe I can share. Yeah, I also download this video.
Let me try whether I can. Let's see whether I can try to play on my browser. Yeah, it seems.
Maybe let me share.
Yeah.
I have downloaded. Yeah.
Okay, please share for me. Thanks.
Yeah, can you see?
Yeah, I can see it now.
Okay. I will play from the starting point.
Maybe yes.
Technology. Now I would like to show you my work in empirical study of multi-discussion.
Yeah, we can hear it.
Okay, good.
Open source software development. My presentation has 3 parts: background, research background, research method, and research result. First, research background. In GitHub, the world's largest open source community and issue mechanism has been set up for technical discussions on bugs in the development process. For developers to put forward problems and solve problems together, generally speaking, it is similar to technical discussion posts for projects. The issues mechanism plays a very good role in promoting the efficient development of the project. We found a very interesting phenomenon in the process of researching the issue. That is, in the same period, the same developer and discussions in multiple issue posts. This is the meaning of our multi-topic. So that they would contribute to the resolution of multiple issues. As shown in the figure, a developer named Otto discussed issues numbered 32941 on May 21st. Then discussed two more issues on May 23rd and 26th, and returned to the original issues on May 26th. This is a typical multi-discussing. As shown in the figure, this is a typical schematic diagram for multi-discussing between two or more different issues. Developer X promotes the resolution of issues through discussion on different timelines in the same time period. First, after our previous coarse-grained survey, we found that there were positive and negative aspects in less multi-discussing. As shown below, positive aspects by paying attention to various issues, developers can maximize their working potential and make more contributions at the same time. There is also negative aspect, that is, if a developer pays too much attention to multiple issues, the attention of developer will be greatly dispersed, which may have a negative effect on the solution of a single issue. Second, in addition, we found that in the mainstream software academic journal conferences, the research on developers' multitasking pattern was mainly focused on the project level, and no relevant research was carried out at the issue level. In view of above research background, we put forward three questions here. First, whether the multi-discussion will have an impact on the overall issue resolution of the project, whether it will promote the issue resolution of the project more quickly or delay the resolution of the overall issues of the project, or it will have no obvious effect on the resolution of the issues of the project, and the correlation is relatively weak. This is the first issue we are concerned about. The second is that multi-discussion has the same impact on the solution of a single issue as it does on the overall issue of the project. Is it possible to promote the solution of a single issue more quickly, delay the solution of a single issue, or have no obvious influence on the solution of a single issue? The correlation is weak. The final question is, what experience or expectations do developers have in the multi-discussing? This information can help us to understand the connotation and the development key to multi-discussion from a human perspective. After talking about research problems, we will focus on the research methods we used, which mainly include the datasets we used and the concepts we've defined. We screened 624 GitHub projects from GitTorrent, all of which had more than 3,000 issues. It should be emphasized that the issue we refer to here is ordinary issue and does not include pull request. In addition, the developer we refer to in the multi-discussing are only for prefer developers, not project members. Second, as shown in Table 1, there was 624 items. First, the average number of developers is 21.4. The minimum is 5. The median is 60 and the maximum is 440. The average number of workers is 2,275. The minimum is 24. The median is 1,132 and the maximum is 93,397. The average number of staff is 7,894. The minimum is 31. The median is 3,167. And the maximum is 215,302. The average number of issues is 6,650. The minimum is 3,484. The median is 5,363 and the maximum is 18,614. From the data, we can see that the projects we selected are of high quality on the whole, which can effectively support the development of our subsequent experiments. For the second research question, method above, we define a concept to discuss focus. Focus defines how quickly and how far developers can change their focus on a single problem in a given week. Postnet and other works inspired us. More attention developers may take more cognitive burden, thus resulting in decline in productivity and quality. Therefore, we would like to discuss exploration, focus the value, to detect multiple, to discuss how to affect a single problem in less work. We use the Shannon entropy index to calculate the developer discussion focus. Next, the third part is research result. For the first research question, we subdivided two sub-questions. The first question is how does multi-discussing affect the average delay in resolving project issues? First, we calculate the issue resolution latency of each issue in the 624 projects. Then we calculate its average issue resolution latency of each project to compare the differences of average issue resolution latency between different multi-discussing percentages. We make the value of percentage from 0 to 10% and as 0.1, from 10% to 20% as 0.2. And so picture on the left shows the box plot of the comparison results. We could find that from 0.3 to 0.9, the average issue resolution latency is gradually decreasing according to the general trend. More multi-discussing in the project seems to bring more benefit to the overall issue resolution. Second, in order to better explore the effect of multi-discussing on the overall issue resolution of the project, we built the regression model. Overall issue resolution model, Model 1, table in the red shows the summary of this model. As expected, the factor MEDPAC has the significant negative effect on the average issue resolution latency. 10% increase to MEDPAC has the effect of decreasing the average issue resolution latency by 0.1 minus 5.9%. Holding all other variables constant, as the result shows, other control variables have little effect on the result. Third, we finally get a finding that for the overall issue resolution, more multi-discussing tends to bring shorter average issue resolution latency. More multi-discussing behaviors may have a positive effect on the overall issue resolution. Besides question 1, furthermore, we want to discuss why multi-discussing tends to bring a shorter average issue resolution latency. As shown in the picture, the instruction pipeline aims to increase the efficiency of executing instructions by dividing the operation of instruction into a number of small steps and performing every step by a dedicated circuit. For example, a task instruction has to go through 3 stages: fetching, decoding, and executing. Each stage takes a machine cycle. If pipeline technology is not used, it needs to take 3 machine cycles to execute. If the instruction pipeline technology is used, when one task instruction has completed the fetching stage and enters into decoding stage, the next task instruction could enter into fetching stage, which improves the execution efficiency of the instruction. As shown in the PowerPoint, we
Hello?
Oh, keep going, please.
What's the
Hello?
problem?
Hello?
Hello? Once again.
Hi, Xiaofei, are you there? Hello, Xiaofei?
What's our plan?
So maybe he is, let's keep going on. Let me try. I think I cannot control Xiaofei's model.
Okay.
The video is is the video is still on? So the video is still play, but the sound is muted, right?
more issues, stars, and for
Yeah, it's recorded.
our datasets. Here we need to rely on the method of defocus to measure the focus of a developer when switching his or her discussion between issues for a single issue. We want to explore how the defocus, a single issue resolution defocus, represents the uncertainty in developers' discussions focus switching, or the diversity of focus switches in given week. The higher the defocus, the lower the entropy. The higher the developers focus on this issue, on the contrary, the lower the focus. The higher the entropy, the more scattered the developers focus and developers have more multi-discussing behaviors. Second, as shown in the right picture, the average focus represents the average defocus of developers in the issue. So the higher end the average focus value, the more multi-discussing behaviors of less issue. We find that the average focus value in over 95% the issues of our data set is between 0 to 10. We mark the value of the average focus from 0 to 10 as 1, from 1 to 2 as 2, and so on. The figure shows the box plot of the relationship between the average focus and the single issue resolution latency. We find that when average focus increases, a single issue resolution latency decreases. The less multi-discussing behaviors in the less single issue, to more focus of developers on less single issue and shorter issue resolution latency. Furthermore, we want to discuss why multi-discussing tends to bring longer resolution latency for a single issue. First, the multi-discussing needs developers to switch back and forth between issues, focusing on a new task and recording previous issues. Developers switch focus frequently due to interruptions. When developers resume an issue after an interruption, they must reconstruct the context of the issue. There is a considerable overhead involved when switching. So for a single issue, if developers have more multi-discussing behaviors, it may make it impossible for developers to concentrate on solving an issue. Multi-discussing tends to bring a shorter overall resolution latency, but for a single issue, the situation seems to have reversed. More multi-discussing tends to bring longer issue resolution latency for a single issue. In the future, we hope to find a balance point that enables developers to achieve their best work efficiency in multi-discussing pattern. Okay, in this part, we ask 6 questions about developers' experience when performing the multi-discussing. Question 1. As shown in the figure 11, 92% of respondents have contributed comments on other developers' issue. It indicates that most of the respondents have different experience in discussing between different issues. Question 2. 65% of respondents said yes. This shows that some developers have to conduct multi-discussing behaviors because they are the project members. Some external contributors also have multi-discussing behaviors even if they're not project members. Question 3. As shown in figure 12, 65% of respondents told us that they frequently participate in multi-discussing behaviors, often or always. Question 4. 73% of respondents reported that they frequently participate in or contribute to open source software communities, often or always. Question 5, as shown in figure 13. 73% of respondents approve that more multi-discussing behaviors are beneficial to the shorter average issue resolution latency. Agree or strongly agree. And 80% of respondents remain neutral on less conclusion. Only 8% of respondents disapprove of less conclusion. Question 6. 57% of respondents approve that more multi-discussion behaviors are beneficial to the development efficiency of a single issue. Agree or strongly agree. And 33% of respondents remain neutral. Just 10% of respondents don't agree with the last conclusion. Disagree or strongly disagree. This result also shows that mixed method have the power to produce precise findings. Our studies confirm that the qualitative study could better understand the context. A quantitative study can better validate hypotheses are correct or subject misunderstandings from qualitative study. In this question, we collected 39 valid answers and we uncovered a spectrum of motivations for participating in multi-discussing behaviors. We summarized the motivations into three representative categories, which are shown in Table 5. 46.2% of respondents reported that their motivation in multi-discussion is to optimize the allocation of human resources and improve productivity. For example, R10 is a company employee with 3 years of GitHub development experience. He or she told us that I want to have multi-discussing behaviors and make full use of my productivity. And 28.2% of respondents reported that developers might switch focuses between issues from the priority perspective. Multi-discussing behavior occurs when developments think that other issues have a higher priority than the current one. For example, R21 responded that I will switch according to the priority of issues. 15.4% of respondents reported that their participation in multi-discussion behavior is a natural behavior when they find some issues are related. For example, R13 told us that we were multi-discussing two issues because we were related to same code module. So we need to switch our discussion between them. In this question, we collect 28 valid answers. We summarize the answers into three representative categories, which are as shown in Table 6. Most of the respondents, 53.6%, reported that the main barrier on multi-discussing is in terms of focus. For example, R8 responded that focus is why I don't easily try to have the multi-discussing behavior solely in future work. It is important to find a balance between focus and multi-discussing behaviors. 21.4% of respondents reported that they don't know which issue should be discussed first. R41 replied that sometimes I cannot aim on target when multi-discussing because I don't know which issue I should deal with first. And 40.3% of respondents think that the coordination between multi-discussing behaviors may cause some challenges or problems. For example, AskC2 raised a very realistic problem. In order to recreate an issue, most users do not provide sufficient information, and coordinating with them is time-consuming. This gives us a notice of discussing activities, whether we should spend time waiting for the exchange of information. The phenomenon of developers multi-discussing across issues is common in open source.
Yeah, due to the time limit, so yeah, we will stop the video here, and we now move to the next session. Yeah, hey, Xiaoning, are you here?
Oh, yes.
Yeah, okay, yeah, you can. Let me give you the. Yeah, now you can take this session.
Oh, okay. So Good morning, everyone. Welcome to the last session before lunch. My name is Du Xiaoning. Currently, I'm an assistant professor at Monash University, Australia. My research mainly focus on the quality and security assurance of deep learning systems and also traditional software to identify the vulnerabilities either in the software systems or the deep learning systems. And in this session, we will have four quite interesting short paper. For each, we will have 10 minutes, with 8 minutes for the presentation and 2 minutes for the question. So if you have some question asking the authors, you can maybe send to the chat bot. I think maybe we can just start the first presentation, which is an audio, and the presentation is on the probabilistic verification of neural networks against the group fairness. And we have Bing Sun to present this one. Okay, so let me know if you can hear the sound.
Hello everyone, I'm Sun Bing. Today I'm going to present this short paper,
Good.
Probabilistic Model Checking of Neural Networks Against Group Fairness. This is the outline of my presentation today. I will start with introduction and motivation, followed by problem definition, proposed approach, research questions. Lastly, I will talk about the conclusion and the expected contribution. In recent years, neural networks-based machine learning has found its way into various aspects of people's daily life, including fraud detection, facial recognition, self-driving, and medical diagnosis. Although in a wide range of applications, neural networks have demonstrated astonishing performance, there are still concerns on their dependability. Among all the properties, fairness is the one that brings much attention, which has societal impacts. For certain neural networks, it will make different decisions for different individuals or subgroups, which will cause individual discrimination or group discrimination and so on. And there are some recent research works focusing on analyzing and improving neural networks fairness, like fairness testing, where they test fairness against individual discrimination and generate individual discrimination instances, or fairness training, where they aim to learn fair classifiers, or fairness verification, which is also the focus of our work. We want to verify if a given neural network's fairness property is satisfied or not. Now let's define our problem. In this work, we focus on independence-based fairness, and the definition is shown as follows. Given a neural network N, it will satisfy independence-based fairness if the protected feature F is independent to the prediction Y. So that is to say, for independence-based fairness, we require the model to output approximately the same prediction outcome for instances which are identical except for certain protected features, and the threshold of this probability difference is defined by sigma. Here we are ready to define our verification problem. That is, let N to be a neural network, phi is an independence-based fairness property. The fairness verification problem is to verify whether N satisfies phi or not. These slides show an overview of our proposed approach. There are 4 steps. The first step is to learn a Markov chain that models the behavior of a given neural network N. Step 2 is to apply probabilistic model checking to verify the fairness property phi on D. And if it is satisfied, we will return as verified and return the DTMC as an evidence. Otherwise, we will proceed to the next step, where we will conduct the sensitivity analysis on all other features and hidden neurons, aiming to identify which neuron or feature is the most responsible for the unfairness. And the last step is we optimize the neural type map parameters identified in step 3, aiming to improve the fairness performance of this neural network. Next, I will present the details of each step in detail. Step 1 is to learn a Markov chain D that models the behavior of a given neural network N. Firstly, why we want to learn a DTMC but not a simple statistical checking? There are 3 reasons. The first one is a Markov chain allows us to perform analysis on unbounded behaviors. In the case of recurrent neural networks, a cyclic Markov chain will be constructed for analysis, while this kind of unbounded behavior is known to be beyond the statistical model checking. Secondly, the learned Markov chain enables us to perform further analysis such as sensitivity analysis, which are challenging for statistical methods. And lastly, as I mentioned just now, if the fairness is verified, the learned Markov chain D will be provided as a human interpretable evidence on why fairness is verified. And the next step is, how can we learn a DTMC from a neural network? And here we need to answer 3 questions. The first one is, what are the states to be included in the DTMC? Minimally, we need to include protected features and prediction outcomes in order to verify fairness. And if we want to perform sensitivity analysis, we need to further include other features and hidden neuron status. And secondly, how to determine the transition probability of the Markov chain. In this work, we propose to repeatedly sample the inputs and feed it into the neural network and monitor the trees of the inputs. The transition probability matrix then can be estimated based on the frequency of transition between states and traces. Thirdly, how to ensure N is estimated accurately by D. We plan to leverage our approach on the recently published work in our reference 1 and obtain the minimum number of traces required to learn an accurate enough Markov chain for our analysis. Next step is the probability model checking. So here we want to compute the probability of getting a favorable prediction for different protected features separately using PMC. After that, we will compare the probability difference against the fairness criteria sigma. If it's smaller than that, we will return as verified. Otherwise, we will proceed to step 3 and step 4. In step 3, we will perform sensitivity analysis on other features and hidden neurons to identify who is the most responsible for violating fairness. And in step 4, we will adjust the weight parameters of identified neurons accordingly, aiming to improve the fairness of this network. In order to evaluate our proposed approach, we address the following research questions. RQ1 is our approach able to verify fairness? We will answer this question by showing whether our method could be applied to verify neural networks against fairness. RQ2 is how efficient is our approach? We will answer these research questions by showing whether our method is time efficient, and we will conduct time complexity analysis accordingly. The third one is the approach able to improve fairness? We will answer this question by showing whether the sensitivity analysis results could be used to help understand where fairness fails and whether our repair can improve the fairness of given neural network. The last one is, are there baselines to compare with? We plan to answer this question by comparing our approach with existing works and report experimental results. Lastly is the conclusion and the expected contribution of this work. We aim to contribute by proposing an approach to formally verify the neural network against fairness property that will learn a DTMC from given neural network with PAC correctness guarantee, and also it will perform sensitivity analysis to identify why the network is unfair if it is the case. And lastly, it will adjust network parameters based on the sensitivity analysis result to achieve fairness. Lastly, we plan to implement our approach on top of Socrates framework, and we will open source the code after the implementation. Okay, here is the end of my presentation today. Thank you.
Okay, so I'm not sure whether Bingsun is here.
Yeah, I'm here.
Okay, so let's see whether we have
Questions.
yes, any questions from the audience? Maybe I can ask one. You mentioned that you want to learn a DTMC from neural network. So here, do you have any assumption about the type of neural networks that you want to analyze?
Yeah, currently we are planning to work on the feed-forward neural network and recurrent neural network. But since we plan to support recurrent neural network, other kind of neural network like DNN may also be supported. The first step is this two.
Okay. So I think these two neural network can be quite different, right?
Yes.
Yes. So you have any idea how to extract this DTMC from the feed-forward neural network?
As mentioned in the slide number 7, so in order to learn a DTMC, we need to define the states we want to include. For feed-forward neural network and recurrent neural network, if we just want to verify the fairness, the minimum number of states are the protected features, the status of the protected features and the outcome. So that after getting the transition probability matrix for the network, we are able to do a PMC on the DTMC to verify if the fairness is verified or not.
Okay.
But for the case with RNN, since it has the recurrent nature, the DTMC we learn will have cycles inside. That's the difference between feed-forward neural network and recurrent neural network.
Yeah. So thank you. So any other questions? Okay, thank you. Thank you.
Thank you
for the presentation and the question answering. So maybe we move to the next presentation. I think we have the speaker here with us, Mengdi.
Oh, yes, I can share the screen.
Yes, the presentation is about toward testing neural network interpretability. Here, maybe I can stop sharing and okay, Mengdi, you can just set up your presentation and start.
Can you see my screen?
Yes.
Okay. Oh, hi everyone. My topic is towards testing neural network interpretability, and I am a PhD student from Singapore Management University. And first of all, I'd like to introduce the current applications of machine learning models.
Sorry, Mengdi.
Yes.
Currently, I'm not sure whether you enter the full screen mode, but I cannot see the full picture of your slide.
Now?
I'm not sure whether it's the network
maybe I
problem.
can stop share and share again.
Sure.
Maybe try to use the full screen.
Yes, you can enter full screen first and then share that.
Oh, okay.
Yeah.
It's now okay.
Maybe Maybe you can click the enter full screen button and I will see. The right hand side behind. Yes, just beside the minus symbol.
Oh, yes. No.
If you do not have any animation, maybe you can start in like this way.
Oh, okay. So first of all, I'd like to introduce the current applications of machine learning models. As we can see in these figures, here are some various real-world applications, from the self-driving cars to the medical image analysis, or some common applications like the language transform or the face recognition. But when we are using these machine learning models, do we really know the insight of the models? For example, as we can see in this example, and here is a neural network trying to predict whether the image is wolf or the husky. But when there is a wrong prediction, as see in the circle, the image is actually a husky, but the neural network predicted as a wolf. We don't know why the model predicts wrongly. And also, if there is a machine learning used by a bank to decide whether to give a loan to an individual, we don't know why such decision is made. For example, why this individual is being denied. So when we face this situation, we propose approach trying to explain a neural network decisions. So from the user's perspective, we want to use a very simple and visual direct explanation model to explain the decisions. For example, here are two explanation models with the same accuracy, which one is more explainable? Obviously, it's the right one, because it's a shadow decision tree and it's human understandable and easy to reason based on it. And so in our approach, we use the shadow decision tree to as the middle proxy to explain the neural network decisions. First of all, we define the decision tree. We limit the decision tree as a binary decision tree, and we are giving a set of atomic propositions from phi 1 to phi 3 in this example, and each phi is a binary proposition. For example, like the age is older than 30 years old, or the income is less than 50,000. So based on this, each node will outcome two labels. One is a true and the other is false. Here we use the key, which is tree dips, as the complexity of the decision tree. And first, we'd like to test the key explainability of the neural network. So the basic steps is that first we generate the decision tree based on this neural network, as shown in this figure. And each leaf of the decision tree is a prediction. For example, like 1 or 0 in binary classification. And if there is for all the possible inputs of the neural network, the outcome of the decision tree and the outcome of the neural network is either exactly the same, we can conclude that the neural network N is key explainable. Otherwise, it's not key explainable. But in practice, it's very hard to approximate a complex neural network with a simple decision tree, a shadow decision tree with dips like 2 or 3. So we'd like to calculates the fidelity of the neural network and the decision tree. So the fidelity here, we define it as the probability of the inputs from a set of all possible samples. And when the output of the neural network and the decision tree is the same, we will increase one, and the fidelity is the probability of that of the samples outputs the same labels. And here we set multiple phi thresholds from 70% to 99%, and we use the sequential probability ratio test to determine whether to accept or deny a certain fidelity. Here is an example. The model we use here is trained on bank marketing datasets to predict whether the client will subscribe a term deposit. And here we limit the decision tree with key as 2. And so there are 3 proposition. The first is F1 is larger than 3 or equal to 3. The F1 here is the employment variance. So if the F1 is larger or equal to 3, that means the employee will change his job frequently. Otherwise, he will have a stable job. And the second proposition is the number of contacts between the employee and the bank is more than 90. And the third proposition is the number of contacts between them is more than 14. We can observe that if the employee has a stable job, and also if the employee contacts the bank more than 90 times, we will conclude that it's more likely for this client to subscribe a term deposit. Otherwise, if the employee frequently changes job, and in this condition, only if the employee contacts more than 14 times to the bank, we will conclude the employee will subscribe a term deposit instead. In the evaluation, we use 3 benchmark data sets. The first one is the census income, which is to predict whether the income of an individual is above 50,000 a year. And the second data set is to classify the individuals as good or bad credits. And the third one is, as shown in this example, is trying to predict whether the client will subscribe a term deposit. All models we use here is 6-layer fully connected neural network. As we can see in this table, it shows the result of the key phi explainability testing. If we set the phi to 70%, we can observe that all the models is explainable. But when we set the phi to 90% or 95%, we can observe that the last model trained on credit dataset is not explainable. And when the key change from 2 to 5, that means the depth of the decision tree become larger and the more complex is the decision tree. Then in this condition, the neural network, we can achieve higher fidelity for the neural network and the decision tree. The last question we will try to solve is, can we improve the model decision explainability using our testing results? If we use the generated samples based on the decision tree to retrain the model, we can see that most models will improve their explainability based on our definition, especially for the last model trained on credit datasets. The original fidelity is 70%, and after the retraining, it can achieve 85%. As a conclusion, the main idea of our approach is trying to generate a new approach based on users' perspective. So we develop algorithms based on decision tree with a height limit to systematically test the decision explainability of neural network. And for the future work, we can extend the approach to further apply to image data or texture data And also, because we need to generate additional samples in our testing, we can sample input with a constant distribution instead of randomly sample in our approach. So that's all. Thank you.
Thank you, Mundi, for your presentation. So let's see whether we have any questions from the audience. So firstly, you mentioned that you try to improve the interpretability of the model with the test case generated during your analysis. So I wonder whether, so when you're improving this interpretability, is there any influence on maybe the accuracy of the trained model?
So after we recheck the model, the accuracy is almost the same. So for all the models, it's almost the same.
Okay, that's good. Okay, so maybe thank you, Mundi. Thank you again for the presentation. And we move to the next presentation. Is from Chen Zheng. And the topic is an efficient binary fuzzing framework with cross-architecture support. And also it's a video, and let me share my screen.
My name is Zhang Chen. I'm going to present you BEEF, an effective binary fuzzing framework with cross-architecture support. First, I'm going to detail the challenges for directly applying fuzzing into some mobile or IoT devices. Next, I'm going to discuss the solutions for each point of the summarized challenges. Finally, you will see our evaluation result and our quick demo. Well, about fuzzing, it is the most effective bug finding methods in recent years. Well, it has been quickly developed in recent years, both in academia circle and in industrial circle. However, if you want to directly apply fuzzing into some programs running inside the IoT or mobile devices, you will find that you have to solve a series of challenges. Where we summarize these challenges as 4 points. First, the running programs inside these devices, we usually do not have the source code, do not have their source code. This means that we need to use some fuzzer, specific fuzzer that can support this kind of binary only fuzzing scenario. Second, these devices usually cover multiple CPU architectures like ARM, MIPS, PowerPC, etc. Well, thirdly, the running programs inside these devices are usually server-like programs. Well, so what is server-like programs? Well, the most common feature of these programs is they will not exit by themselves. For example, the HTTP server inside an router device or an APK application running inside an Android phone. This program will never exit by themselves unless a user forces it to. This means that this kind of program has a different life cycle comparing with the traditional command line programs. Well, fuzzing this kind of program requires additional techniques. Finally, these kind of devices usually have limited performance. Well, we further conduct an investigation to show that how current solutions solve these challenges. Sadly, we found that current solution cannot solve them well. We think that there requires a new general solution. Well, to solve these challenges, we build a fuzzing framework. Well, our solution to these challenges are layered. Therefore, I will introduce these solutions to you layer by layer, from the innermost layer to the outermost. First, at the beginning, we first developed our own hooking framework called Scorpio. This hooking framework uses a technique called dynamic binary instrumentation. This provides us the ability to hook any assembly code inside the target program without their source code. Well, this is the foundation for further building a fuzzing framework based on it. Well, our hooking framework covers several CPU architectures, including Intel, ARM, MIPS, PowerPC. Next is we further define several strategies to fuzz server-like programs. Remember that the life cycle of the server-like programs is different. Therefore, we developed a fuzzing framework which could provide us the ability to customize the start, the feedback collection, and the end of each of the fuzzing. Well, this means that basically we could control where to start the fuzz, where to end the fuzz, and we could fuzz any pieces of the binary code inside the target program. And we further developed the additional workflow to fuzz this server-like program based on the framework. Finally, to further speed up the fuzzing, we integrate several algorithms. We choose two algorithms, which is both lightweight and effective. First, we try to penetrate the hard conditions inside the program. We integrated Stulix, which could figure out the magic bytes inside the program. Second, we integrated Cerebral, which uses a multi-objective algorithm to help us find the next most promising seed. About we further compared our fuzzer with the existing solutions. We found that our fuzzer is most suitable for the scenario that fuzzing a program inside some IoT or mobile devices. We are the best one to fuzz server-like programs, and we support more CPU architectures. About the performance, we conduct some repeated experiments. We found that BEEF is the most effective binary Olin fuzzer. In some cases, like NM, it even has close speed as the source code fuzzer, the original AFL. Well, finally, I'm going to show you the quick demo. The demo shows how we use our fuzzer BEEF to fuzz an APK file inside the Android phone. First, we open the demo APK file. Well, our BEEF can be used to fuzz the native code inside the APK application. You can see this demo app. Once the user clicks this click button, it will call some native functions inside the third-party libraries inside this APK. You can see once you click the button, the Android system's message will record the background function calling. It will call the C function handle content. Well, next we configure our fuzzer to try to hook the start, end, and the feedback instrumentations into the application process. After successfully hooking the target application, we switch to the target APK and click the button again. This triggers our hooking logic's execution, which could give us the interface to fuzz. Finally, we start up multiple instances of fuzzing. Thank you.
Okay. So Johnson, are you here?
Yeah, I'm here.
Okay, I think maybe we can take one question. So for the evaluation, you mentioned that for you show the figure that you compare the performance between Beef and several other tools. So what does this y-axis mean?
Can you switch to that slide?
Yes, here.
Thank you. Well, the y-axis means the age coverage of the targeted program during the I'm sorry. This y-axis means the executions per round.
Execution round.
This means that the unit is that how many times you execute the targeted program in 1 second.
Okay, so yeah. So the AFL SRC means the original performance, the performance of the original AFL.
Yes, because original AFL requires the source code of the targeted program, so it can finish the instrumentation during the compilation. So it seems that it should have the fastest speed.
Okay, I know. So thank you.
Okay, thank you.
So maybe we quickly move to the last presentation. So thank you, Chen, for the question answering and the presentation. So the last one is adversarial attacks of anomaly detectors with AI for cyber physical systems. And I will play the record by Ethan.
Hello everyone, this is Ifan. It's a great honor to present my research topic in the Internetware 2021. My research topic is about AI security and testing in cyber physical systems. I'm from Singapore University of Technology and Design, and also I'm an AI engineer in TUSUD Asia Pacific. So firstly, I would like to introduce my motivation. I believe you have heard that there is a self-driving car kill a woman by accident. So with the faster development of Industrial 4.0, there are many cyber physical systems has been widely used. And also there are many applications in safety and security critical environments, such as self-driving cars, malware detection, drones, and robotics. And deep learning models has been widely used, but they are vulnerable. So what is a cyber physical system? It includes a cyber parts and the physical parts. Physical parts include sensors and actuators. So sensors take information from the environment and send to the cyber parts, and cyber parts do the analysis and send commands to actuator to do some action. And so my research topic includes two works. The first one is about adversarial attacks of anomaly detectors in water treatment systems. So for this work, our main contribution is like we have defined a threat model for CPS adversarial attackers, and also we propose a gradient-based attack for deceiving an RNN-based anomaly detectors and also the rule checkers. And we implemented our adversarial attacks on two systems. One is a water treatment system called SWAT, and another one is a water distribution system called WADI. We have successfully reduced the accuracy of the detector around 50%, and also we evade the detection by the rule checkers. So there's an overview of our attacks. The system includes a physical parts, which are sensors and actuators, and also a cyber parts. There are PLCs and SCADAs. We apply the noise through the network, and the noisy data will be sent to the cyber parts. So finally, lead the system give a wrong prediction. So our methodology, so there are two defense mechanisms inside the system. The first one is called an RNN QSIM anomaly detector. So it works like they put around 12 seconds data into a long short-term memory neural network predictor. And the predictor will predict the data of the next second and will compare with the actual data of the next second to calculate the error. The error will be accumulated and compared with the threshold low and threshold high to finally determine whether this data is a normal or under attack. So what we want to do is like we want to attack this anomaly detector. So originally the system gives data and data pass to the anomaly detector. The detector will tell you whether it's normal or under attack. But we will apply the noise to the data. So the system, when the data is normal, the system will tell us it's an attack. But when the data is attacked, the system will tell it's a normal. So that's our purpose. However, there's another defense mechanism called rule checkers inside the system. A rule checkers works like to compare the values of sensor and actuators. So there is an example of the rule. For example, the sensor LIT101, if the value is smaller than 500, then the actuator ME101 must equal to 2 after 12 seconds. So all the values of sensor actuator should obey the rule. So this is how it works. To overcome the rule checkers, so we have proposed a genetic algorithm. So the workflow is like this. The data from sensors and actuators will be applied adversarial attacks, and the noisy data will pass to the rule checkers. If it has passed the rule checker, means like the rule checker didn't find the attack, then the noisy data will be given to the anomaly detector and finally give a wrong prediction. But if it has been caught by the rule checker, we will use the genetic algorithm to pass rule checkers, and so the noisy data can finally go to the anomaly detector and give a wrong prediction. And we evaluate our methodology in the two systems with 3 research questions. So for the first one, is our attack effective? And we found yes, it is effective, and it can reduce accuracy from around 90% to 30% in the SWOT system. And the second research question is like, how could we compromise the data to deceive both rule checker and the anomaly detector? And as we propose that we use genetic algorithm to optimize the actuator value and to finally attack the two defense mechanisms. And the third question is like, can we design a defense mechanism to against the attack? And we found that it's very hard to design a defense model if we do not have any information about the adversarial samples. So this is my first research, and also there's another research topics that is related. It's about adversarial attack of object detectors in the robotic arm. So our contribution is like we propose a method to generate adversarial patches and to make the object detector give a wrong object location of the objects. And also we have achieved physical effects and achieve a targeting location attacks. Motivation is like there are many advanced manufacturing and they have a lot of interaction with humans, including the cobots. They are safety critical and low fault tolerance. So our the system we focus on is a robotic arm. It looks like this. There's a gripper to click the object, and there's a camera mounted on the top of it to detect object. So the attack scenario is like we want to attack a card detection mechanism. So firstly, we present a card, and then the camera will start to capture the card. Card will be sent to the cloud to do the analysis and send the card location to controller. Controller will ask the gripper to move to the location, but we will put a patch on the card. So the image is noised and attacked, and the algorithm will give a wrong location of the card, and the gripper will finally move to our targeted location rather than the red location. So what is a YOLO version 3? YOLO is an object detection mechanism. It can tell you where and what an object is. So we want to attack this algorithm inside the system. There are similar works. For example, a work called dpatch. There is an example. Is like initially the YOLO can detect an object like the bicycle, but if they put a small patch on the corner of the image, and then the algorithm cannot detect anything. Similarly, if they put a patch, the algorithm sometimes can detect like multiple things or detect wrong things. But for this work, they didn't make it physicalized, and also they are not targeting to attack the location. And this is what we do. We have a methodology is to train the noise. We have an initial random noise, and then we put the noise to the image and feed to the algorithm. And then according to the output of the algorithm, we calculate the loss and then do a back propagation to update the noise. And finally, we train the adversarial patches, and we have done some testing on the images. So for digital one, there is an example. Original detected card center is like this. So we can see that this center is correct of the card. And there is an untargeted attack. It's like we put an untargeted adversarial patch here. We can see the center of the card has been to this part, which is a very random one. And also we have a targeted attack patch. We stick the patch to the image, and then our target is the human's hand. And we can see the algorithm tell us the center of the card has been somewhere of the human's hand. And we also test our algorithm in the real world. We printed the patch and stick on the card. We can see initially the algorithm works well after the patch has been addicted to the card, and then the algorithm sometimes cannot detect anything, or it can detect multiple things. So anyway, it gives some errors. And we have do this one on the robotic arm. There is our video to tell about the untargeted attack patch. So this is a view of human, and this is a view of the camera. Camera is here, and this is a gripper. You can see it detect the card, and also the gripper will follow the card, but it cannot detect where the actual card is. So finally, the gripper cannot determine and then go back. So this is an untargeted attack. And also there is a targeted attack. We want the robot to hit human's hand rather than click the card. So you can see there's a similar setup. Views of human, the robot, and the camera view. So the camera detecting the card, and then the gripper moves. But it detects a wrong location, and we can see the gripper has clipped human's hand. Okay, so this is our second work. And that's all. Thank you.
All right. So thank you, Yifan, for the talk. So I'm not sure whether Yifan is here.
Yes, I'm here.
So I think it's quite interesting work, but the patch currently generated look quite obvious. So it's a large area on the card.
Yes, so this is our initial work, and for the future work that we were trying to optimize it and to see if we can make it more practical for the industrial usage.
Okay. So I'm not sure whether we have any other questions. Well, if not, maybe we can end the morning session here, and maybe you can have a 2 hours break and come back to the session in the afternoon. So thank you, Yifan, again for the presentation.
Thank you.
All right, so I think maybe we can stop here. So bye-bye, see you.